So, what we're going to do today into our turn-based game is actually stop creating the grid on runtime, well, sort of, and then after we have created the grid, then read for colliders inside the scene, and if that scene has colliders, then it looks where that collider is, on what node it lies upon, and all that. Instead of doing that, we're going to take a level that we have previously created it into our level editor. We have a video on that which we did a few months ago. Okay, we're going to take that level and we're going to load it from there, and we're also going to load all the references that you see that basically for cover. Okay, all that is going to be created when we actually make the level. Now we're not going to focus about pathfinding in this video. This is mostly tailoring the level editor, the runtime level editor we had there, just to make it to tailor it for this project basically. Okay, as I said, if you remember that walls shouldn't be blocking the whole node, they should just block the current side they are. Okay, and that's what we're doing over here. But if it's an obstacle that covers the whole node, then you cannot go to that node and so on. And none of these objects has now any colliders on them. Okay, so we're going to focus on making menus and all that on a later video. We're now going to focus to enable the level editor node with just the tick over here. So if this is the level editor, okay, similarly as we did before, I can actually go make the level, place objects, whatever. Okay, create walls with the wall creator we had before, paint everything and all that, and then save the level. Now I do not want to save this level because I like the other one better. Okay, and if I click the load level, it's going to be loading the new level and so on. Well, let's actually create a sort of a level and we can see this. Okay, let's build a wall for our level. From side, let's build a few more or whatever, something like that. Let's add a bit of texture, and something is not working right over there. Yeah, probably. Yeah, anyway. Okay, you get the idea, and if you saved and then reload the level, you can play on that level directly. So before we see the changes we're going to see in this part of the project, we need to go back into the level editor, to the runtime level editor project, and do a few changes there. So basically the only changes we have to do into our runtime level editor is actually go into every script and add a namespace to its own script. Okay, just go into every script. Previously we only had a few that have to do with the level editor. You simply need to go into every script and add namespace level editor. And we do that because on the other project we also have scripts that are called grid base, node, and of course node object, node references, and all that. So we want to include this project exactly as it is into a new project, and of course we were doing that and have classes that have the same name, we're going to be getting errors. But since everything is under its own level editor, that makes it so that the classes are separated by the namespace. Okay, so you need to go into all your scripts and add the namespace. Then create a folder called level editor and drop everything that you have inside from your runtime level editor. Then export the package, and this is pretty much ready. Now it's going to include the models that we had and the textures and all that. Okay, we basically need everything. So with that package, if you export it, you have a package you can use for any game you might want to add the runtime level editor. Let's go back into our turn-based game. So back into our game, after we have imported the level editor, we will have this folder and we will have everything in. If you did everything correct, then you won't be seeing any errors. But before we start integrating one with the other, we need to focus a bit on organizing our game basically. So in-game scene and start scene. Start scene is this one, which also includes the level editor and all that. The previous scene we had is the in-game. In-game, I'm basically just keeping the canvas I had before and the level manager. Everything else is redundant. Let me start. The cover indicator, of course, although I think we are creating that, so it won't matter. Okay, and directional light and your canvas. We're keeping it as it is. We made the camera holder as a prefab and we use that into the start scene, but I do not assign it over here and you will see why. And I've also deleted the event manager the event manager that comes with the event system that comes with the canvas. Okay, so back into the start scene. We now have the scene that we were using on the level editor. We have the canvas and the level manager, but we want something to control what exactly we want to do, so we're going to create a new script called Session Master. So basically the Session Master is going to take references for the level editor, which is the level editor grid, which we have into our level manager, the level creator reference, which is the script that creates the level, that allows us to create the level, the reference to the canvas, which is this one, which is the buttons basically, and the loader, which is the script that loads resources that we call when we actually want to load the level or save the level, but in our case we're only going to load at this time. Now let's go into our Session Master. It takes a boolean and the references that we take. If we want to enable the level editor when we hit play, we're going to use this. On start, we will return to actually create the level. What exactly creates the level? It goes into the level editor. Keep in mind that we're going to use 2 grid bases and a few other nodes, so the namespace is important here, and that's why I didn't include the using, and I include the namespace directly or where I want the reference, so that we do not confuse ourselves. So it's going to call into the level editor's grid base, which is this one. Let's go directly, let's not use pick. Okay, go definition. If you want to see this, how to make this more in depth, you need to go into the runtime level editor videos and follow that. So previously we had this on start, but now this was start, I want to make it a public. I'm calling it init, and when I want to run the start we had on the previous videos for the runtime level editor, okay, I'm going to create a new reference, a new game object reference, which is going to be called the grid holder, and of course I'm creating on start and changing the name, and the reference is over here, and then create the grid and create the mouse collisions. Now for the grid we're going to add a few more stuff both on the node. Keep in mind that this is the node for the level editor, not the grid master we had for the turn-based game. And right now I do not do anything with the Y, so we're going to focus only for two-dimensional grids right now. Later on we'll see what we're going to do. So the changes I did on the level editor is add on the node of the level editor, add a reference to the node object, new object. Okay, so I need to actually go and assign the node object now. I get the node object, and for the node and the node object script, I basically added a reference for one to contact the other. So I have a variable so I can save the actual node inside my node object, and inside my node I saved my actual node object. Okay. So in the way we were doing it for the turn-based game in our prefab, which the new prefab we're using is the one from the level editor, it's the floor. Previously we only had, for our turn-based game, we only had the node references. Now we're going to use both the node object and the node references. The node references has to do with the turn-based part of the game. The node object has to do with the level editor. Okay, so for starters, that is the big two changes we have to do. We need to save on the node object we save the node, and on the node we save the node object. Now on node object we actually added a few more stuff. I've added a list of covers which take from the world UI, which is the actual covers we're using on the turn-based game. So previously we were looking if there are colliders inside the node and assign the covers like that. But since we can now place everything we want, we have more control over our level, we need to know also the references for the covers. So we start with a list, and I've actually created a constructor for my node object. So every time I assign the script, it's going to basically run this constructor, which is going to initialize the covers list. It's going to add 4 covers, and it's going to assign the direction for each one. Okay, north, south, west, east. Then we're going to use a few functions we used on the previous turn-based videos, which is set cover status. You pass the direction and pass the status. It finds the direction inside the list and then changes its status. And the other thing we're going to change is, because we actually want to save our level, we're going to add on our node object saveable, we're going to add integer for every cover status we have. We're going to save the enums, and if the node is actually walkable or not. So when we are calling the get saveable, we also need to pass all that. So for every cover status, we take the enum and turn it into an integer. Okay, and if it's walkable or not, we control it. We see if the actual node is walkable or not, and that's why we use the new reference over here. Okay, so back into the session master. The first thing we see is that we actually create a level. What this does is creates an empty grid with the tile painted the default color. Okay, we have our grid, we have the base for our level. Now if we want to use the level editor, we're going to go into the coroutine that goes enable level editor. What this does is basically enables the UI of the level editor, which should have been it controls if we have enabled the level creator, the actual script is enabled or not. It's controlled by the boolean level editor, and the UI is also controlled by also the same boolean of level editor. So it will run this, and if it's enabled or not, it's going to be controlled over here. And the actual enable level editor is basically going over here, say, just, yeah, it might be a bit redundant to have this one, but let's just keep it, and we can delete this one. Okay, it creates the level, and you can, from there, you can actually, it's all about the job that the actual level editor we made does. Okay, so if we want to actually play and not use the level editor, then we're going to say we're going to assign the level save load into our loader. Now the level save load, previously we didn't have a singleton, so you actually need to go into your level save load script and add it. And we did a few changes over here, but we're going to see it in a bit. Okay, basically the singleton is this one. Okay, you know, I'm assuming you know how to set up singletons, and we're going to see it in a bit. Okay, and since we do not want to create a level, we want to load it, so we call the function to load the level. We also need to make this function public. From there and on, we need to actually load the new game scene. So we here return scene manager load scene async, the first scene, the second scene, load scene mode additive. We want additives because we can use, we want to keep the level that we just created, the level that we just loaded from the level editor, from here. Okay, so when it actually loads that level, it's going to then start initializing the level. To initialize the level, you will see that we have a level editor grid base, the editor grid, we save it over here. Then we go into the level initializer on the level control, which we had on a turn-based game. We get the instance, since it was a singleton, and our grid stats. Previously we only had this one. This stuff we're not using them anymore, so you can actually delete them. But I won't right now because I might have them on some references. The only thing I've added over here is make a reference, the public, the level editor grid base, not the grid base you have here. Okay, not the grid base under grid master and level control, under this grid master and level control, but the grid base that's actually from the level editor. Okay, and I call it pre-made grid, so I know what grid that was. Okay, I have assigned it there, and then call the level initializer. I actually change the start from here too, so instead of using start, I'm using public void init, so I actually can control when I want this to be initialized, which what this does is creates or loads the grid, starts creating, initializes the level. Okay, everything else is kept the same instead of except from where we actually create the grid. So when we are creating the grid, it goes all that. It creates a new game object with a grid prefab and all that. Okay, it gets the game object similar to what we were doing before, grid, and then it calls the function to init grid. But as you see, not as you see, we had this before. We are also passing the grid stats. So on our initialize grid, let's go to the definition. We were doing all that, we were passing references here and there, and then we were creating the grid and we were reading that afterwards. But now we're going to check if the grid stats has a pre-made grid assigned, then it's going to go into this new function we're going to see, which is called load grid. And if it doesn't, then just write a debug log. Okay, because that's an error and we do not want to be creating the grid from here anymore. So to load the grid, the other functions we're going to keep them as they were. we do not have to worry about them. So to load the grid, we also need to pass the grid base we had on the previous from the level editor. Let's see the load grid. Okay, we initialize the grid we have in this script in the turn-based part of the game and not on the level editor, and we basically pass the variables we have on our loaded grid. Now, instead of having max x and max z, I'm using the same max y, okay, and I basically use the size x from the loaded grid and the size z from the loaded grid to initialize the grid. Now, I'm not adding anything on our level object since I'm only going to focus on two-dimensional grid right now. So, I want to store an array for node objects that come from the level editor. And I go into my loaded grid, into my grid holder, and get all children that have all components that are in children's that have the component of level editor node object. Okay, and for each node object I save in here, I come and create a new node. I pass the references I need to pass, so I initialize this new node with x, y, z from that node position. It's basically where we do the connection between the nodes we are using in the level editor and the connection between the nodes we are using inside our game. So I pass the variables I need to pass, x, y, z. I pass the world object, which in the case of the node object is the actual game object. The node reference is the get component node reference, and that is why on our prefab we need to have also a node reference component now and the node object. And I pass the covers list inside my node reference from the node object. And if it's workable or not, it's controlled by what we have stored previously on that node. We assign on the grid on the positions we are passing over here from the and position x and z. I just keep the zero as the y. Okay, we assign the new node, and this is garbage. Okay, and this way we just made the connection between the old nodes we were using with the new nodes. So over here I think, yeah, we're not using the create grid anymore. We are using the load grid, and we also do not use the read level anymore, and not the create cover positions. Okay, so this way, this was the actual connection between one grid system and another grid system. It's fairly simple if you think it a bit. It might look a bit complicated, but yeah, we just done it I think in 15 minutes. So moving back to the session master or manager, whatever. Okay, we have loaded the grid we have previously made with the editor, with the level editor. We have assigned that grid to the grid we are using inside our actual game. We need the reference to the game grid because we also need to assign the offsets we had on our editor grid. Okay, and then we simply call yield return null, and this comes back over here. And since we have said on our level initializer to actually start initializing, then that means you are ready to start playing the game exactly where we have left it before, our project basically. So what we did up to now is basically coming over here, hitting play, and something didn't work. Yeah, I should have probably do not delete this one on create level. Yeah, because otherwise it's going to be keeping it open. So, up till now, okay, we've covered everything from playing that play button, loading the level, and be back to exactly where we were before. Okay, and I'm ready to play and all that. Of course, there's no pathfinding that avoids the walls. It can avoid the obstacles, but right now it doesn't avoid the there is the problems with the covers, which we'll see in a later video. Now, the only change we have to do right now is when we are on the level editor to actually go, let me maximize this. Basically, when I'm placing an object, I have to say on the neighboring nodes that there is an obstacle over here, and on that node that you cannot walk on it. And when I'm creating a wall, and yeah, this takes it so that it's a click. So anyway, so when you create a wall like this, go and inform the neighboring nodes that at this side, this node at this side, it's not approachable, so it has a wall. Right now, as I said, or I think I said, we will only focus on making full cover. On a later video, we're going to make it to actually check if it's full cover, if it's partial cover, and all that cool stuff. It might look a bit confusing and a bit difficult, but this is going to enable us a world of possibilities, especially with procedural generation and all that, and with level readability. And this is all lightweight. There is only one single collider at this moment in this scene, so it's very lightweight. So you can imagine that you can use it into a lot of different types of projects. So we need to go into our level manager, into our level creator, to our level editor, not level creator, and basically the way we were keeping everything and the way we have set everything up. Okay, we have our functions where we are placing an object and when we are creating a wall. The only change we need to do is when we are placing an object, which is an obstacle, basically you need to go and say into all neighboring nodes, go and change the direction looking towards the obstacle and change it to a cover status. Before we see that, we're going to see a new function. The new function we're going to see is this one, update neighbor nodes, which is going to take the current node, it's going to take a direction, which is in our case vector 2. Later on we can make it a vector 3. Although you probably do not you can handle the above layers or floors and all that a bit differently, but it also depends what type of game you are making, of course. It's going to take a world UI direction and a world UI cover status. I'm keeping the namespace over here because otherwise you might get confused and ask why you get an error and all that. So this way I think you won't be that much confused. Although if you are, of course, it's not a beginner project. Of course, it's not even an intermediate project. It's a very advanced project what we are creating over here. So it's understandable. Just take it slow and you will get there. So moving on, we basically take the direction in a vector 2. So instead of having two integers over here, we can just use one vector 2, but we have to round them to an integer. And we also need to add the current node position x and z. for each case. So basically, you pass the direction to look from the node you are, from the current node you are. You find the neighboring node on the grid base that has to do with the level editor, and I've also added a new function into the grid base that has to do with the level editor. Okay, level editor grid base, and the new function is public node get node. You pass a node, you pass two integers. It looks if they are inside the bounds of the grid it has, and then it returns that node. Okay, very simple. We have seen this before. If the neighboring node is the current node you are, then do nothing, just return. We do this because if you are on a node that is close to the edge, if you are on a node that it's over here, the neighboring node is going to return this node, both for this. Okay, so you don't want to do any changes on this one. You already did it, or not already did it. You basically control this one differently. So just return, don't do anything else. On the neighboring node, on that node object, set the cover status with the direction and the cover status we have passed. We see this, we saw this function on the previous video. And basically not on the previous video, we saw that we write that on the previous video, but we copy paste it into the node object 2. We saw that on the previous video we saw it on the node reference. We're going to use when we want to do changes into our scene on runtime when we are playing the game. Basically, let's say you throw a grenade or something like that and breaks a wall. Okay, the changes we're doing on the cover status and on if it's workable or not on that node, we will do them on the node reference. The changes we do when we actually create the level, we're going to be doing them inside the node objects. And since we right now create the actual level, we're using the node object, the functions we have over here basically. Okay, and it changes the cover status. We do not want any of this. We have some changes on the delete wall, but we're going to see it in a bit. So on the update wall, we were on creating the object. All that is for the wall. Create wall update, destroy current node. Okay, we do not want any of this. Create wall node. Let me just close them. And we were over here. So we're placing an object. We have created an object. We assign the reference to the current node. We say now that node is not walkable anymore. On the east, we basically now need to say on the neighboring nodes what everything needs to be. So you go and say update node from the current node -1 position on the X, which is the east node. Go and change the west direction to cover status full. On the north node, go and change the direction, the south direction, cover status full. West node, the east direction, and south node, the north direction. And in scene game objects, add them to the actual game object place. What we were doing anyway. Okay, this is how you set an obstacle, and you update the neighboring nodes that they have cover from that direction. When you want to delete a game object, an object, you need to do that again, but I want to keep the deleting objects separate, so I'm not going to show it. I haven't implemented yet, because when you actually delete a game object, you actually need to check if there was a wall, and you need to check all that. So it will have been cluttered just for that. So just keep in mind that right now, if you delete objects, it's going to be a few problems. So that is for now for placing objects. Let's go into placing walls. Now the way we have set it up, everything in its own functions and everything, the only thing we need to change is inside the update wall node. If you remember, we were simply calling from that node, from that wall object, on the update wall, we were passing a direction. Now we're going to use a switch and we're going to check the direction, and if that level wall object was wall direction AB, AB was having a wall, AB was this part of the wall, BC was B and C. Okay, it's A, B, C, the way we have said it over here. So, with that in mind, if this node has, or yeah, let's take this node. If this node has a wall on the AB side, that means it has a wall on the south side. So, the node that should be over here on the north side means it's actually blocked, it has a wall, so it's blocked. So we come and say, if the wall direction is AB, go to the neighboring node on the south. So you change your own first, of course. So you say on your south direction you have cover on full, and then call update neighbor nodes. Get node the south to take the south node. You do this -1 on the Z, and you say on your south node on the north direction you have cover full. Similarly, with the BC direction, you go find the west node and you say on the east node, on your east direction you have cover status to full, and you change your east direction and you go on your east node and say on his west direction it has covered full. Okay, and finally, if it has both directions, both AB and BC, you go just copy paste that to this. Of course you can encapsulate that into their own functions, but it works the same, and it's not stuff you will be doing all the time, so who cares? Okay, that's how you update your wall. And if I go, let's see it again, if I come and draw a wall or something, yeah, basically this one should have, this probably doesn't work, and that's why you get that errors, but it's not a problem. We should focus right now. So basically I set up a wall over here. Okay, so if I go into my node, find my actual node, then I can see into both my node object list, and the node reference are empty basically because I did not use I'm not inside the game mode, I'm in the level editor mode, so it doesn't update this list yet. So this node, it has a wall on the south side, and you can see it from here, direction S, status full on the covers list. So on his south node, of course this node has from this part also, from this direction too, you will see that on the north direction it has cover full, and also since this node updated this node too, on the west direction it also has cover full. When we are doing pathfinding on a later part, we're going to also take into account these variables, and you will see how cool it will be there. Okay, so with that in mind, we basically finished with this, integrating the level editor. It was pretty easy actually. So when we want to delete a wall, when we were doing everything we were doing before, we only need to come over here and say, before we destroy that wall object, check for each cover we have into that current node object into the cover list. So for each cover it says the cover, you have a cover anyway. Do a switch for each direction for each cover basically, and if they have, basically you do not even look if they have something or not, just goes and sets the cover status for the respective direction. So if on the south direction, it's going to go into the south node and change the north direction of the south node to be cover status to none, and so on. Okay, pretty simple, pretty easy, and I think if you give it a bit of time, you won't be having problems with all that. Now, of course, as I said, this will also have to you also have to think about the what I said before. So basically, because you can have, if I place an obstacle and on that obstacle I also have a wall, okay, yeah, it needs a bit of tailoring, of course, as everything does. So, okay, this is the obstacle. This node has cover status from here, and it should probably have from here too. But the problem is, if I delete the wall, it's going to update the node and say that on your north direction you have cover status. Okay, so that's a problem, but we're going to tackle it on a later video because it needs a bit of thinking. And right now, yeah, it's basically a few if statements. Check if that has a wall, if that has an obstacle, and basically, why not? Let's just do it over here. Let's just say if if current node dot is walkable, only then do it. So basically with this, if you are deleting an object, or if you have another object, an obstacle inside your node, okay, then it should be unwalkable. If it's unwalkable, that means even if you have a wall or not, the directions of the neighboring nodes are going to be staying the same. Okay, so probably the way I thought it right now, it should work without much of a problem. I hope so. Anyway, and let's see if we can actually, since we have a bit of time, if we can actually create or add the delete part of the placing object. Delete object, delete objects, delete object, destroy current node, place object prefix. So let's say if a current node wall object is null, then destroy the current placed object. Else, here's the tricky part. So right now we need to know if our current node has covers into get cover. How was it? Let's pick the definition. Node object, set cover status. Yeah. since we only know that we can have from the south direction and from the north direction walls, okay, and then no, let's start by changing all the directions we can have. Current nodes, an object, no, update neighbor nodes. We pass the current node, and we will start with new vector2 -1 0. If I add a 1 over here, it's going to include the diagonal diagonally nodes, but I do not want to do it right now. So world UI dot cover, no, what does, forgot what tag, world UI world direction. So on the east node, we need to add, no, on the west node we need to add the east direction, so we'll simply say cover status none. I could probably just copy paste that from the wall object, of course, or no, on the place object. Let's take all this, since there's no point into rewriting them, of course. Okay, and change the cover status to none for everything. So what this does, never mind, it doesn't mind if it has, yeah, let's keep this like this basically before we destroy the game object. And this gets an error because this, and we're going to say at the end destroy. So we destroy the game object, the placed object, and we go and update all the neighboring nodes that do not have a cover status. Now we can check if the current, before we destroy the placed object, if the current node object has a wall object, current node, come on, wall object, then we need to find the actual wall object. Let's pick the definition, what we have. We need to, we can check basically the wall direction. If current node dot wall object dot wall direction. So instead of doing that, let's just add a simple switch. And start adding cases. A, B, B, C, and wall direction dot wall. Okay, so we have we basically know we can copy paste what we had into our wall when we're deleting a wall, and it was delete wall actual, it was over here, not over here, or was it over here? No, yeah, instead of doing that we can do this actually. So we take this, whoops, I'll take the all, and come back to delete object and copy paste it into the all. I'm going to change the get node, of course, to current node. And let's format it a bit, and I think it was oops, it wasn't. Yeah, there is an auto format, but I forgot what it was right now. So anyway, you get the idea. It's basically I get the all on the all, and then I can take the south direction, which is on your current node. You change the cover node and you say set covered node, set cover status. Yeah, we get south direction on the AB, use this one. As you can see that the whole point of the whole bulk of this code is just copy paste. Okay, since it's stuff we have done before, we just simply add a function here and there, and then we can simply just go and change the stuff. And I hope we have done this correctly. Okay, so this on your wrist, and then you change. Okay, it's correct. So with this should probably work, whatever. Let's test it. Let's create a wall. I want to have, yeah, a wall like that. I'm going to place an object. Let's check the nodes. Now this node though will have a problem. Okay, so basically for 3 directions it says it has cover, it's full. Okay, both for the neighboring nodes, both for the other directions. So we actually need to do this for each. We need to check all the neighboring nodes if they have a wall. So that's a bummer, basically. So let me think a bit. So what I did is a bit of encapsulation. So what we just wrote, I put it into its own function. Okay, update node with the wall direction, and I'm basically passing a node. It checks if it actually has a wall object, and for each wall object it has or not for each wall object, depending on the wall direction it has, so AB, BC or all. Okay, it just does what we just wrote. Now that we have the encapsulation, and since we know that this is going to take care of the south node and the east node or the west node, then we can simply come and say, and this will be east node. Yeah. Okay, we can simply come and say, do this update node with wall direction for the current node. Find your north node with grid based get node. the node position X that has the current node, and plus his use the current node's node position Z plus 1, update node with wall direction for the north node, do the same for the east node. Okay, the east node is of course the current node's position plus 1 on the X, and then update node with wall direction for the east node. And let's test it. We're going to hit play. I'll place a wall. It got placed by itself. Place another one and another one. I'm going to let's add an obstacle that's more easy to see. Okay, I'm adding an obstacle or whatever. I'm going to come over here and say, well, basically I'm going to check the node. So previously the way we had it, if this works, if I delete this game object, this obstacle, the north direction of this node should keep his cover status to full since it has a wall. Okay, let's try it. Okay, it works just fine. So I'll end the video over here. I think it's we have done something pretty good actually in our case. Just keep in mind to delete the reference from the in-game scene. Now, of course, you do not actually have to load an additive scene. You could just load the stuff from the start scene, but it's best to have them separated, so it leaves you more doors open to do more stuff in the future. So later on, this is going to enable us a world of possibilities later on. Okay, and we're going to make a menu later and going to focus on making more cool stuff. So with this you will be able to have something like this, an actual level which you can create and make. Now of course every level you create, it's going to overwrite the previous one, since we always save it on the same file. We're going to see later what we can do about that and everything else. So I'll end the video now. You know what to do. Don't forget to like, subscribe, and also if you want to see more videos like this and more cool stuff, then consider supporting me either on Patreon or grabbing a project or two from Gumroad. And I'll see you next time.